Hello friends, we have been talking about linear equations in one variable and linear equations in two variables. Now let's consider two equations. This equation is a linear equation in one variable, whereas the equation x plus y equal to 200 is a linear equation in two variables. First, let's concentrate on this equation. For this equation, x equal to 5 is a solution since it satisfies the equation. Now, can we represent this solution on the number line? Of course, we can easily represent this solution on the number line. So, consider a real numbered line. Now, we have to simply plot 5 on this number line, and we will do that with the help of a dot. So, this is how we can plot the solution to the linear equation in one variable. Now, what about the equation x plus y equal to 200? Here, we know that there will be infinite number of solutions to this equation since this equation is a linear equation in two variables. And the solutions will be of the form ordered pairs in x and y. Some of the solutions are 100, 100, 60, 140 and 80, 120. Now, how can we represent these solutions? Is it possible to represent these solutions on the number line as we did for the linear equations in one variable? We cannot use the previous method since the solution here is in the form of ordered pairs and ordered pairs cannot be represented on a single number line. Then how do we represent these solutions? So, to represent these solutions, we basically need two real numbered lines. Think for a minute. Where do we get two real numbered lines? It's in the Cartesian plane, right? In the Cartesian plane, we have two perpendicular lines, x-axis and y-axis. Let's see how we can represent the ordered pair 80, 120 on the Cartesian plane. When we talk about representing ordered pairs on the plane, we consider the first number to be x-coordinate and the second number to be y-coordinate. So here, 80 is the x-coordinate and 120 is the y-coordinate. Since the numbers 80 and 120 are large, it won't be possible to represent them on a plane with scale 1 cm equal to 1 unit. So what will we do now? Now, we will use a plane with scale 1 cm equal to 40 units so that we can represent these numbers on that plane. Next, to plot the numbers, we always start from origin. First, let's look at the x-coordinate, that is 80. So, we have to move on the x-axis to 80. So, here is 80. Now, the y-coordinate 120. Now, from 80, we will move perpendicularly to 120 and this is our required point 80, 120. We can represent the same point in the other way as well. That is, from the origin, we first move 120 units in the direction of y-axis and then we travel 80 units perpendicular to that direction. And then we will reach the same point 80, 120. In simple words, we can say that the point 80, 120 is a point which is at a distance of 120 units from the x-axis and 80 units from the y-axis. Also, the point 80, 120 is at a distance of 80 units along the x-axis and 120 units along the y-axis. So, in this way we can represent the ordered pair, that is, the solution to the linear equation in two variables on the Cartesian plane. Now, since we understood how to represent the ordered pair, is it possible to represent the linear equation itself on the Cartesian plane? Do you think that is possible? Yes, that's possible, and let's see how we do that. Let's see how we can represent the same equation x plus y equal to 200 on the Cartesian plane. The answer lies in its solutions or the ordered pairs. Now, to represent this equation on the Cartesian plane, we need some solutions of this equation. Let us say we need some 4 solutions. Now, how do we find 4 solutions to this equation? Finding 4 solutions may sound complicated, but let me give you some tricks. We can actually do it mentally. Let's consider x equal to 0. Then y must be equal to 200 since x plus y is equal to 200. Now, if we consider y equal to 0, then x will be equal to 200. Again, if we consider x equal to 50, then y will be equal to 150, and if we consider y equal to 50, then x will be equal to 150. So, what do we do with these values? We know that these values are nothing but the coordinates, and we just saw how to represent the coordinates on the Cartesian plane. So, we simply have to represent these points on the plane. So, let's do it. So, to plot the point 0, 200, we don't need to move on the x-axis, since the x coordinate is 0. We just have to move on the y-axis to 200. So, this is the point 0, 200. Similarly, we can represent the other 3 points, and the other 3 points are 200, 0, 50, 150, and 150, 50. Now, do you notice something special here? If you observe carefully, all these points seem to lie on a line. Let's connect them. If we connect them, we can clearly see that all these points will lie on a single line, and if we extend this line, we can conclude that all the solutions to the linear equation x plus y equal to 200 will exactly lie on this line. Now, let's take a different point on this line. Let's say this one, right? What are its coordinates? Its coordinates are 100 and 100. Now, is this ordered pair a solution to the linear equation x plus y equal to 200? Just simply substitute them and check. If we do so, we can clearly see that this ordered pair 100, 100 is a solution to the linear equation x plus y equal to 200. Do you want me to check for one more point on this line? Let's do it. Let's consider this point. So, the coordinates of this point are 300, minus 100, which will obviously satisfy the equation x plus y equal to 200. So, we can conclude that even this point is a solution to the linear equation x plus y equal to 200. So, every single point on this line will solve this equation x plus y equal to 200. And how many points are on this line? They are infinite, right? Now what about the number of solutions to this linear equation x plus y equal to 200? Even they are infinite as well. So now it must be making sense for you. So this line is the graph of the linear equation in 2 variables. Now, do you understand why this equation has been given the name linear equation? It's because the graph of this equation is nothing but a straight line. But what about a point that is not on this line? That is, if the point is not on this line, will it be able to satisfy this linear equation? Let's check. Let's consider a point minus 100, 0. So we simply have to check whether this ordered pair will satisfy this equation or not. If we substitute the values of x and y, and if we see the LHS is not equal to RHS, which implies that the ordered pair minus 100, 0 is not a solution to the linear equation x plus y equal to 200. And that's the reason this point is not on this line. So we can conclude that the graph of a linear equation in 2 variables is represented by a straight line. And on that straight line, every point is a solution to that linear equation in 2 variables. If the point is not on the straight line, then that point will not be a solution to the linear equation. So friends, I hope you understood how to represent graphs of linear equations in 2 variables. In our next video, let's see some more graphs. As of now, let's summarize what we have learned so far. The solution of a linear equation in two variables is an ordered pair. In representing the ordered pair on the Cartesian plane, we consider the first number of the ordered pair as the x-coordinate and the second number of the ordered pair as the y-coordinate. The graph of a linear equation in two variables is a straight line. Every solution of the linear equation represents a point on the line. Every point on the line is a solution of the linear equation. Any point which does not lie on the line is not a solution of the linear equation.